Alright, it is time for us to begin a brand new section. In this section, we are going to continue our discussion from Volume 1 on flow control. So in Flow Control 2, what we're going to be looking at are loops. Basically, how we can take a section of code and repeat that section over and over and over. Now, we've got several different types of loops available to us. We've got do loops, we've got while loops, for loops, and then there's for each loops as well, though we're not going to be introducing them here. They've got their own special place. We'll be introducing them to you a little bit later. We also need to take a look at some ways that we can manipulate loops, because you can force a loop to stop or just to skip an iteration altogether. There's just a few things that you can do, and it's definitely handy to know how to do these things. And then we're going to wrap the whole thing up with a knowledge review. We want to make sure that you get a clear understanding of how to apply loops. Now, before we get started with do loops, let's first find out why would you want to have a loop. So for that, let's come over here. We shall discuss it on the whiteboard. A loop is a way of simply repeating a section of code. Let's pretend that we've got a game, and in this game we have 4 enemies. You'll always have 4 enemies. You cannot kill the enemies. The enemies do not spawn. You just have 4. You start the game, there's 4 enemies. That's it. You just always stay away from the enemies. Let's say as each iteration of the game loop runs, we need to check with each enemy, find out where they're at, find out where the player is at, move towards the player, and then see if we've actually touched the player. So with each one, we're going to have this area of code that's going to be like kind of an update for the enemy. So we'll just call it enemy.update. And we're going to do a check. See how this, talk about pseudocode, right? It's going to be symbols here and drawing squiggly lines. So we're going to do a check, then we're going to move towards them, then we're going to check to see if we've touched them, and then we're going to kill them if so. You get the idea. The bottom line is this. This needs to be performed on each enemy. So there's 1. Then you'd come down here. And I'll only do 2 of these. So we check, we move towards, did we hit them? Death, so that would be for enemy 2. So enemy 1, enemy 2. Now, we are rewriting code if we did it this way. So this code right here would be the exact same down here. And then the exact same down here. And finally for the 4th one. This is not efficient. You would not want to program this way. Instead, let me go ahead and come in here real quick and just knock some of this out. You would want to contain your code in a loop structure so that we can simply have the code repeat. So if I was to come up here and say that we had some sort of loop start, and I'm just going to say loop if we need to continue looping. Now this area of code is going to execute. So all those lines of code execute. And then when we get to the bottom, what are we going to do? We'll simply loop all the way back around and begin execution again if the loop is required to run another iteration of the code within. That is the idea of a loop. Check it out. We've only written our code 1 time. Oh, so much better. Think about this. If we had to reproduce this code 4 different times in the very simple example I presented a minute ago, what would happen if we went back in there and we made a change, just testing something out, right? We're like, I don't like the way that the enemy is moving. Let me just check with enemy 1 if I change this. Okay, that's pretty, and we come in here and we just start tweaking the one enemy, but we forget to copy this code and paste it with the other 3 enemies. Now we've got a problem, don't we, Logan?
Right, we might have bugs where undesired behavior left on those other enemies.
You got it. So having a loop, by coming in here and making changes, these changes are going to affect everybody because this code is being run over and over and over for all of the enemies that are there. Now, the example that I gave you presented a scenario where we only had 4 enemies. Now, we saw that we were able to go in there and reproduce our code 4 different times. What if we, on the other hand, had a situation where we could have enemies die or enemies spawn into the level? So let's just pretend that they can die. So we started out with 1, 2, 3, 4, 5 enemies, right? So here's enemy, 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 enemy. if we were to try to code these out by hand, and then this guy died, so here's the code, 1, 2, 3, 4, 5. This guy down here died. Now, in all of our code for all of these guys, we're going to need to check if they're alive or dead before we run that block of code. That's going to get kind of nasty. And, of course, we're also still dealing with the same problem where we could go in and tweak one section of code. Again, it's supposed to be exactly the same through all of these guys, but we could tweak one section and accidentally forget to copy it to all the other sections, and now our code's no longer, I just want to say valid. It's not really valid anymore because it's supposed to be the same for each enemy, but it's not. So we've now introduced undesired effects or bugs, like Logan just said a second ago. So that's something we really got to keep thinking about while we're working. By putting this in a loop, if we were able to control the loop, which you can, you could say loop through the number of enemies that are currently alive and perform the following code. So once again, we have just one section of code, and our loop is designed in such a way that it will address every enemy that is alive at the moment and perform this code right here. So that code is not performed for this guy because he's dead. All right, so that presents a little bit more of a sophisticated scenario, but we could still handle it with this structured setup right here where we're reproducing the code. We just have to put a check inside each section saying, is the guy alive or dead? What if, as we are playing the game, enemies spawn in? Now you've got a whole new problem. What if you were going to try to code it out in this fashion right here where you're not using a loop, you're just copying and pasting the code over and over and over for each enemy? Let's say we're playing a game where we don't know how many enemies are going to spawn into the game. How are you going to write that out? Now it's impossible. What are you going to do? Write 5,000 sections of duplicated code and have a check to say, yeah, if this guy happens to exist, run this code. No, you're not going to do that. Again, we're going to come in and set up a loop that is going to simply account for everybody that currently exists. So all this fancy schmancy stuff that I'm throwing out here on the whiteboard, it simply boils down to this. If you've got code that needs to run over and over and over again, why copy and paste it over and over and over? Put it in a loop. Let the loop cause it to run over and over and over. You're just looping code. That is all. So in the next set of videos, when we go over the do while loop and the while loop, the for loop, the examples are going to be kept extremely simple. I just want to get right in, make my point, and get right out, because there's no reason to make loops really complicated, because they're not in the end. What it's going to boil down to, when you're looking at a complicated loop, is how you're setting it up with the expression inside for when that loop needs to jump out. And in most cases, it's relatively simple. Every now and then you might find some fancy stuff in there. But that's the plan of attack. Now we have an idea of why we need loops. Let's go ahead and progress with this section of videos and talk about the loops that we can use and how we set them up. Let's go ahead and get started.